In 1965, IBM released a computer that would teach a generation how to program. The IBM 1130 was small enough for universities, powerful enough for real science. Now you can learn its assembly language right in your browser, the same way students did 60 years ago. The 1130 uses 16-bit words and a simple register set. The accumulator holds your working value. Index registers let you loop through memory. Load, store, add, shift, branch. These instructions built scientific applications across hundreds of campuses. The IBM 1130 arrived in 1965 as a breakthrough in affordable computing. Universities finally had access to real computing power. 16-bit words, 4,000 words of memory, and a powerful instruction set. Over 10,000 systems trained the next generation of programmers. The simulator includes an IBM 029 Keypunch. Watch as I type on the virtual keyboard. Each character creates a unique pattern of rectangular holes in the card. The 1130 read these patterns to load programs and data. Cards held up to 80 columns of information, one character per column. The 1053 console printer uses Selectric type ball technology, printing at about 15 characters per second. Watch as it outputs an assembler listing on green bar paper. Each line shows statement number, memory address, hex object code, labels, and source. This sample implements a counter loop with arithmetic instructions. The ball element rotates and tilts to strike each character through the ribbon. The green and white stripes helped operators read across long lines of output. Here is the web interface. On the left, a menu with tutorials and examples. In the center, the program editor, where you write assembly code. On the right, registers, flags, and a memory grid showing 48 words. Watch as I work through a few examples, starting with basic arithmetic and building up to indexed addressing. Watch as I assemble this program that adds two numbers. The machine code appears below with hex encodings. I step through instruction by instruction. The accumulator loads 5, adds 7, and the result 12 appears with the positive flaglet. Now, a more advanced example using memory-mapped registers, the 1130 stores index registers at addresses 1, 2, and 3. Watch the memory grid highlight as values flow into these locations. The indexed addressing loads from address 50 plus the index register. The mode selector knob controls execution speed. Turn it to single instruction, single phase, or single cycle to watch registers change step by step. Engineers use this to trace program flow, verify timing, and diagnose hardware faults. I have used the toggle switches to enter machine code directly. The console toggle switches let you enter 16-bit values directly into memory or registers. Flip each switch up for 1, down for 0. Engineers use these switches constantly for bootstrapping the system, loading test patterns, and debugging hardware faults. When disk or tape failed, toggle switches were often the only way to get the machine running again. The IBM 1130 taught assembly language to thousands of students. Its clean architecture makes it perfect for learning how computers really work. Memory-mapped registers, single address instructions, condition flags, these concepts still apply to modern processors today. This is an early proof of concept. The goal is to connect to real IBM 1130 emulators, add more devices like disk, tape, and plotter, and demo higher-level languages like APL and Forth. Stay tuned for more. Try the emulator yourself. No installation required. The link is in the description. Work through the challenges to master 1130 assembly. If you enjoyed this look at computing history, like and subscribe for more explorations of classic systems. If you found this helpful, please like and subscribe. Hit the bell for notifications, and leave a comment if you have questions. See you in the next one. Bye.